In this video, let us see about the Quine McCluskey method. So, the step-by-step procedure is given and you also learn how to check your answer. What is this Quine McCluskey method? It is also used to minimize the Boolean function. We have already seen about K-map, which is used to minimize the Boolean function. But in case of K-map, when the variables are less, when the input variables is 2, 3 or 4, it is easy to apply K-map to reduce the Boolean function. However, when the number of variables increases, for example, take this 5 variable K-map, you can see you need 2 squares, that is 16 cells plus 16, 32 cells to reduce the Boolean function. So, when the number of variable increases, K-map becomes complicated. In such cases, we can go for this Quine McCluskey method. Let us see how this is done. So, you take an expression, you see here f is equal to a b c dash d plus a b c d. So, here 3 letters are common. A, B and D is common in both the cases. I am taking it out. So, bracket is C dash plus C. I can write it. What is C dash plus C? Anything, any letter and its complement will be always equal to 1. That is 1 plus 0 is equal to 1. So, this is equal to 1. So, I can write F is equal to A, B, D. So, you can see that when the minterms are changing by only 1 bit. So, in this case only C bit is different in both the cases. You can eliminate that bit in the final expression. So, according to this method, you have to identify 2 terms which differ by 1 bit. You see here the same expression and writing in terms of zeros and ones. For A it is 1, 1. For C dash I have taken 0 and again for D 1. And here A, B, C, D, so all are 1. So here D in both the cases only the third bit is differing. Okay, remaining bits are same. So if it is such a case, what I am going to do is I am putting a dash here and I am eliminating that corresponding bit from the final expression. So, I will get the answer as A, B and D. So, by this way, you can eliminate as many literals as possible. These are the steps to be followed to solve the Boolean expression using Quine McCluskey method. So, the steps may not be clear now. After doing the problem, you will understand what it is. First, you have to group the minterms according to the number of ones present in the binary representation. Then you have to check for 1 bit change. You have to put a dash symbol and again the process repeats. Then you have to find prime implicant, then place a dot. So, all these things you will understand as you do the problem. So, first let us see the first problem. Simplify the Boolean function using Quine McCluskey method. So, the expression will be given. You see here sigma m of something is given. So, what does this represent? All these are minterms. So, let us tabulate the minterms. So, the question is here and we will mark all those minterms here. So, M0, M2, M3, M6 like that you write all the minterms and its corresponding binary value. Now, the first step is that you have to group the minterms according to the number of ones present in this binary equivalent. For example, you see here M0, all 4 zeros are here. So, this will be the first term. Second, you see here only a single one is present in the binary equivalent. So, that you have to find. So, this M2 has only a single one Again, if you see M3, it has 2. So you come to M8, it has 1. So these two have only single ones. Then this has 2 1, this has 2, this has 2 1, and this also 2 ones. Remaining have 3 ones. So now I am going to rewrite this table according to the number of ones present in the binary equivalent. So let us write M0 first, then M2. After M2 you should write M8 because it has only one single one. Then we will write M3, M6, M10 and M12. So this should be in ascending order. Okay. Then 3 number of ones. So you have to rearrange the table like this. So first step is over. Next step, there are 4 groups now according to the number of ones. So here group 1 there is no 1. In second group 1 is there. In third group 2 ones are there, and in fourth group 3 ones are there. So like this we have grouped and 4 groups are there. One condition is that always you have to compare with the adjacent group only, that is below group only. Okay. So G1 should be compared with G2. G2 should be compared only with G3. G3 should be compared only with G4. You cannot compare G1 and G3. Okay. So G1 always with G2. G2 means it should be compared only with G3. Now we will compare first group and second group, G1 and G2. So M0 and M2 I am comparing. So if I compare these two, only one bit is changing here. Remaining 3 bits are same. Only one bit is changing. So I am writing it as 0 0 dash 0. So this is how you have to write. That is, you are eliminating the differing letter. So third bit is changing, so that alone you put a dash. Now you have to put a tick mark for these two terms. That is, whenever you compare two numbers or two minterms and you write this combination, you have to put a tick mark for these two minterms. Okay. So here I have M0 and M2. So for those two minterms I am putting a tick mark. This is very important to put a tick mark because it will define the final answer. So always remember to put a tick mark here. Next we are going to compare M0 with M8. So in this case also there is only one bit change. What you will get? The first bit is different, dash 0 0 0. So here I have included 8. So I have to put a tick mark for 8. Okay. Already 0 is included, so you can leave it. So all the 3 terms are now ticked. Next we have to compare G2 with G3. So now let us draw another table and mark these things here. So I have compared 0 and 2. You can either write M0, M2 or simply write 0, 2 and write this binary equivalent. And again we have compared 0 and 8. Note down that also. Okay. So G1 and G2 comparison is completely over. Next we will go to G2, G3 comparison. Now in G2 we have two terms M2 which should be compared with all the 4 terms here. Again, mi should be compared with all the 4 terms. So first let us take m2 and compare with 1 by 1. So m2 comma m3, you see only one bit change. So mark that here. m2, m3, you can mark it in the table directly. Again, m2 and m6, one bit change is there. So mark it. So for m2 and m6, one bit change is there. We have marked it. So put a tick mark immediately. Okay. Next, m2 and m10 also one bit change is there. So you compare this one and mark it here, 2 comma 10, that also you mark it here and put a tick mark. Next, if you see m2 and m12, there is no possibility for one bit change, so you can leave it. Next we will compare m8 and m10. M10, again you have one bit change is possible, so you are writing it here 8 comma 10 and its equivalent binary value. Next we are comparing 8 comma 12 and write it. So group 2, group 3 comparison is over. Next we should go for group 3 and group 4 comparison. So don't forget to put the tick mark because 12 is here, so put a tick mark here. Now we will compare m3 with m7 and then m3 with m13. So m3, m7, one bit change is possible. Mark it in the table. So 3 comma 7 marked it. Again m3, m13 not possible. One bit change is not possible. Then m6 and m7, one bit change is possible. So 6, 7 you can mark it here. Next, if you compare 10 with other bits, nothing is possible. So let us go to 12 and 13. So here one bit change is possible. So 12, 13 possible. So you have finished all the comparisons. Before proceeding to the next one, check whether all the minterms which have come here has been ticked correctly. Okay, don't miss out any tick, because if you miss some ticks, that will come in the final expression. So always check all the minterms has been ticked here. Whatever it is coming here should be ticked here. So this part is over. Next, we are going to follow the same procedure or repeat the same procedure and compare this group with the second group for this table also. So we have this table. Here all are zeros, here ones are there, here two ones are there. So this is single one and this is double one. So same procedure, we are comparing 0, 2 and 2, 3. So when you compare 0, 2, 2, 3, nothing will come. Actually it is easy to compare here. You check for the dash. So third bit we have a dash. You check which third bit is having a dash here. So you check these two. So one bit change is there. Only the first bit is different. So remaining things are same. So let us mark it here. 0 to here 8 10. So you write all the numbers, then you write the binary equivalent dash 0 dash 0. Next, this one is not possible, so we will compare 0, again same procedure, put a tick mark. Then 0 8 can be compared with, you see here, first dash is there, you check for first dash, here it is there. So you check 0 8 and 2 10, 0 dash will come, the same thing will repeat because the minterms are same thing will repeat. So let us not write again, you just put a tick mark alone. So we have put the tick mark. So first two rows comparison is over. This group 1 and group 2 comparison is over. Next we are going to compare this second group with third group. This 2 3 you see here, final bit, last bit we have a dash, so you check for a dash in the last bit. So check for 1 bit change in 2 3 6 7, 1 bit change is possible, so you mark it here 2 3 6 7 and write the corresponding binary equivalent. Then you can 2 3 with 12 13, no, 2 bit, no, many bits are changing, so this is not possible, so you leave it. Next 2 6 with these things, 2 6 and 3 7, again same combination 2 6 3 7. So you put a tick mark alone for these two combinations. So next we will compare the other bits, and 2 6 3 7 it has been already included, so just put a tick mark alone. So you will check for any other comparison is possible. I hope no other comparison is possible. Okay, now the important thing to be noted here is there anything left out without putting a tick mark? It's here, you see 8 12, you check here 8 12 is there, no, only 8 12 is not here. Similarly 12 13 is not here. So these two are left out without a tick mark. This should be included in the final solution. Again, if you come to the next table, you cannot compare these two. So these two are also left without any tick mark. So 4 expressions will be there in your final answer. One is this 8 12, one is 12 13, and these two things. Let us see how to write this one. So you mark those things clearly, whichever is left out without a tick mark. Okay. All these 4 we are going to put it in a table which is called prime implicant. So prime implicant without the tick mark terms we are writing here, and its binary representation. For this binary representation we can write the letters, that is literals. You see here, this is 1 dash 0 0, it means that A, B is not there, C dash D dash. Here it is A, B, C dash. Here A is not there, so B dash, D dash. Like that we can write for 4 prime implicants. These are called prime implicants. Now you have to tabulate this prime implicant like this. That is, this is prime implicant. You have some minterms here. Write all the minterms here. So 0, 2, 3, 6, 7, 8, 10, 12, 13. All the minterms you make it as a column. Now first what is here? 8 and 12 is here. So you go to M8, put a dot here. Then for M12 you put a dot here. Again for 12 you put a dot, and 13 another dot. Then for 0, 2, 8 and 10 you put the dots. Here 2, 3, 6, 7 you put the dots. Okay, first step is over. So first step you have to write all the minterms, and then in the corresponding column for this 8, 12 you put a dot. Okay, this is over. So first what we are going to do is identify column with one dot. So here you see this column M0, it has only one dot. M3 has one dot, M6 has one dot, whereas M2 has two dots. So I am going to find the single dot columns. So M0 put a tick mark, for M3 one dot, M6 one dot, M7 one dot, then M10 is having one dot, M13 one dot. So you finish this one first. Now you have to put a tick mark in the corresponding prime implicant. You take this one dot column, you go and see the corresponding prime implicant, put a tick mark. Now for again M3, which is the prime implicant here, so you put a tick mark here. For M6 it is already included, M7 already included, M10 already included, and M13, so just include this one also. Okay, so first step is you are identifying the one dot columns, then for corresponding prime implicant you are putting a tick mark. Next what you are doing is you have to search for two dot column. In two dot column this M2 you see both the terms are already included, and here M8. So if you see this term, it has been already included. M8 you see already included, so no need to put a tick mark here. Okay, so this particular term can be eliminated from the output expression. So here also you see M12 is already included, so there is no use of including this one. So your final expression is f is equal to abc dash plus b dash d dash plus a dash c. So this method looks very complicated since we are doing for 4 variable. Actually, when you have more number of variables, this is the easiest method. You may get confused whether what you are getting is correct or not. So let me give you a simple method to check your answer, because normally this question comes in 16 mark. So to get full marks, you can check your answer before you are completing the exam. Okay, so it's very easy. How to check your answer? Put a K-map for the same problem. You put a K-map. Okay. So the same thing I have marked here. Now you see here 4 variables are there. Let me combine this one. So what is the term? What is the common term here? A bar, then C. So A bar C. Then in 4 n's we have 1. So let us combine this one and find the variable. So this is common term is B bar, and here common term is D bar. Then this is A, B and C bar. A, B, C bar. So your answer is all these 3 terms. So you check with the answer what you got earlier. This should match. Actually you left one term unticked there. Okay. So that term will come in the answer if you combine these two ones. But this is not essential because all in ones are already included. So this is the answer. So if you want to related video about 2 variable, 3 variable and 4 variable. All links are given in the description. And one more example also in the same Quine McCluskey method I have discussed in chapter 16. So in this Read Electric Vehicle channel, we have a material for power electronics, solid state drives, digital electronics, circuit theory and basic electrical engineering. If you want any material or any topic to be addressed other than this, you can mention in the comment section. Thank you. If you like the video, subscribe to Read Electric Vehicle channel. Thank you.